continues. This is our last chapter for math studying. Okay, so you may not learn math at all later for your whole life. So just enjoy the last chapter. Okay, sampling and estimation. This is not really belongs to probability chapter. It is called statistics. Okay, so this is the new chapter, and I believe in this year you will have more questions about stats in the exam because this is already the third year we learn that. Who write exam will expect teacher is doing better, teaching better now in this topic. I have a great understanding on that already. So we'll focus on this chapter, and then there are three different types of sampling. We talk about like three different distribution we use. Let's use the word distribution. There are three types of distribution we use. Okay, let's go through first of all why we do sampling. Okay, population and samples. The set of all eligible members of a group which we intended to study is called a population. So we want to study the 17 years old girl in Australia. So everyone is 17 years old, is a female, will be eligible member, and that's make up the whole population. Often dealing with an entire population is not practical because of mainly three reasons. The first reason can be population is too large. For example, all these 17 years old girl in Australia, how many are there? Like there are a lot. You can't really talk to all of them. You can't really investigate on like their weight, their height, like what they study, what they like. Like it's very hard to get all these informations. So that's the first reason why we need a sampling. Okay, why we need a sample. We don't talk about the entire population. The second reason is the population may be too hard to access. Okay, example we have is the fish. We also talk about a kind of fish 100 meters down under the sea. Okay, it's hard to get them. Maybe there's not many of them, but like it's hard to grab all of them and find them. And how do you know we have to get all this data? It's hard. So it's hard to access. It's another reason. The third reason is the data collection process may be destructive. I also talk about the life of a battery, how long I can use the battery for how many hours on average. You're not going to use all the battery in the supermarket and just to see, oh, I want to find the average value and I use 100 like batteries. It's not going to work in that way. So that's why another reason we need sample. It's possible to use all the batteries. I just make using them and also see how many hours they can be used. That's possible, but do we really want to do that? If we did that, you can't really sell them anymore. So that's the third reason why we don't do it. So too large of population, hard to access to the population, or when we try to collect data from that, is destructive like process involved. So three main reasons why we need that, why we need sample now. So select a subset of a population is called a sample. Okay, called a sample. For example, our class can be a sample of 16 to 17 years old or 16 to 18 years old girls in Melbourne. Like can be one sample like this class. A well-chosen sample will give much useful information about this population. So what's a well-chosen sample? Like it needs to be a random sample. A random sample, a sample of size n is called a simple random sample. If it is select from the population in such a way that every subset of size n has an equal chance of being chosen as the sample. In particular, every member of the population must have an equal chance of being included in the sample. All right. For example, I also talk about. For example, I want to investigate all the year 12 girls. Okay, what average ATA they can get. Okay, over Melbourne. You're not going to use this sample in our school. Like you're going to pick 20 of you as a sample because you're doing too well. Like it's not the average level of the state. You need to select maybe some from our school, some from the low behaving, like low achieving school, some like from the middle ranking of the school. Like you need a mix of that, and then that sample can represent a good population. Otherwise, if you just use 25 of you, you may all do above 90, and that's not a fair sample. Like because everyone's doing above 90, 100% of students doing above 90. That's not a good sample. So we need a simple random sample. What we select you as a sample is not random. Okay, it's not random. Okay, this all definitions is not really helpful. In order to make a valid conclusion about the population from a sample, we would like the sample chosen to representative of the whole population as a whole. This means that all different subgroups present in the population appear in the sample in a similar proportion as they do in the population. Okay, so for example, I want all the subgroup with the same population. If, let's say, if I have 100 in school A and I have 200 in school B, well, I don't care what I'm talking about. Like say in school A and school B, I have 100 and 200. Like let's assume this is too large to talk about every single one in this population. I want to select a sample. If I want to select a sample of 3, I want to select a sample of 3. I need to have 1 from school A and 2 from school B. That means the sample will have the same proportion, similar proportion as in the population. So it's 1:2 ratio, and when in my sample I want a 1:2 ratio as well. But that's the ideal case. Okay, that's the ideal case. If we have that, that's a really good sample. But can we always get that? It's very hard to get that. Okay, that's just my dream, like of aiming to get that. We're aiming to get that. All right. Come here.
Oh, really? Can I have my lunch, miss? Thank you.
Ask for too many things. You're required to enter and you're required to eat your lunch. What else you want to require?
I already paid before.
Okay, let's look at example 1. In X high school, 50% of 4, 9, 6, year 11 students are female, and 55% of 380 year 12 students are male. What if a sample size of 100 required from a survey, how many year 11, year 12 boys respectively should be selected? Okay, let's have a look. We have year 11 and we have year 12. And I have boys and I have girls. Have boys and I have girls. How many year 11 students we have? 4, 9, 6. How many year 12 we have? 380. How many year 11 boys we have?
No, oh no, in the question, okay.
Eat your lunch. It's okay, finish your lunch first. Well, 288. And we have 288 girls as well, so half for year 11 and year 11 boy and girl. And how many year 12 boys we have? 55% of the year 12 are male. So what I should do is 380 times by 0.55 to work out the value. Where's my calculator? Come on.
209.
209. Wait, what?
248.
Let me have a look. 380.
Oh, sorry, bad.
Oh yeah. 298, right? 248. Yeah, 248. can't do simple math now. 209 for that, and 380 times 0.45 is 171. Okay, so this is the separate year 11 boys, year 11 girls, year 11 boys, year 11 girls. How many students are there in total for 2-year level? $496 plus 876, right? That's the total number of students in the school. Okay, now I want 100 sample, like 100 students as sample, and I'm asking for year 11 and year 12 boys respectively. Okay, so year 11 boys, you also see what's the proportion of year 11 boys in the school, which is 248 over 876. That's the proportion of year 11 boys in the school. And I will times this by 100. Okay, times this by 100. That's how many boys you want. You want the same proportion in that 100 students. You'll have about 28. You have about 28. For year 11 boys, we want similar proportion. Year 12 boys, there are 209 year 12 boys, 876. Okay, we have about 24. Okay, rounding 24. Okay, this is the proportion. You want similar proportion for the whole population compared to your sample. Okay, you might have a simple multiple choice question like this in the exam, like a simple one, like which the following sample will represent the best chosen of a random sample. So you want to see all the same proportion. All right, next thing I want to talk about is really important. There's a population proportion and a sample proportion. There are two different things. Okay, so what's a population proportion? What's a population proportion? Okay, a population proportion is the actual proportion of something in the population. For example, for 17 years old girl whose height is over 160, there will be an actual population proportion. Well, maybe I don't know that. Maybe the population is too large, it's too hard to calculate. Maybe it's an unknown value, but the God will know that. Okay, there will be a value, a true value. Say 70% or 72% of the 17-year-old girl will go above 160 centimeters. So this is some value that never changed. Okay, in this period of time, it doesn't change. Okay, if your population doesn't change, then this rate doesn't change. So this is a true value. Okay, I will say this is a true value. It's a fixed value. It's not going to change. It's something certain. It's just purely for your whole population, for everything. And you want the eligible members, the ratio, you find the ratio eligible members compared to the whole population. Okay, what's a sample proportion? Okay, what's a sample proportion? Sample proportion, again, I'm trying to talk about 16, 17 years old girls whose height is above 160 centimeters. And I'm select, for example, 25 of you as a sample. Okay, I can count maybe 10 of you is above like 160 centimeters. So it's 10 over 25. Is my sample proportion. Is according to the situation I have for the sample, I calculate a value for the proportion. But think about that. If I use next door, or not next door, next door, or like that classroom, the 25 girls in that room, do you think I will get a same ratio or a different ratio? It might be a different ratio. It's not a certain number, because in that class they might play basketball, everyone, like it's just taller, everyone's above that. I can have 100% sample with height above 160 centimeters. It might happen, okay? And I use this L204, that room, as like the student in that room as a sample. I may have a different sample space, right? Like, and a different sample proportion as well. So according to different sample, this p hat value will keep changing. Okay, this p hat value can change, can vary between different samples. I choose you as a sample, I can have 10 out of 25. I can use the next door as a sample, I may have 24 out of 25. And I use downstairs, maybe have 1 out of 25. Like, it can be all different. Okay, it can be all different. It purely depends on what sample you select. Say if you select a really bad sample. You know, like in China, we arrange students from the shortest to the highest, like that's how you arrange students. And then you go into the classroom and you also pick sample. Let's pick all the second row students, like first row and second row students as a sample. What might happen is they're all quite short and none of them is over 160 maybe. So you're not choosing a good sample. You're choosing a bad sample because you are not covering all the different people. Like you're aiming for the first row and you know they're short. So I might have a sample with 0%, but like all of the p hat value, it won't change my p value. Okay, it won't change my p value. P value is the true value. It doesn't matter what happened. It is the actual proportion for the whole population. But p hat is a value varies between sample to sample. That's something you should understand. So the population proportion P is a constant value, a fixed value, a constant value. P is a constant. P hat is a random variable. Okay, P hat is a random variable. You can vary between sample to samples. And if it is random selecting, if it's randomly selecting samples, what's the probability I can select this sample? Okay, this is a mix of proportion question and probability question. How easy I can select this class as a sample? How easy I can select next door as a sample? Like, what's the probability to get this particular sample? What's the probability to get next door as a sample? So I'm talking about probability as well. I have all different probability to reach all different sample proportions. Okay, I have different probability to reach sample proportion. I will show you an example later. Okay, I'll show you an example later. There are 100 people in the room, 40 males and 60 females. A random select of 6 people and investigate on the proportion of females in the room. Talk about the P and P hat. What P equals to in this question? Talk about investigating on proportion of females. What's the proportion of females for P? Yeah, 0.6. Okay, this is my actual proportion. Like, in this room, there are 100 people and 60 females. I know my proportion will be 0.6. Okay, think about my P hat, or I'll use a capital P hat to represent. What my P hat can be? I'm selecting 6 people, right? I'm selecting 6 people. How many men might be there? Let's say, how many females might be in the 6 people? How many females are there in 6 people? Might. Yeah, 0, 1, 2, 3, 4, 5, 6. I may have no females in the sample. I select 6 men. I may select 5 men and 1 female. I may select 2 females and so on. So I can have, well, I will use, say, number of female. I can have 0, 1, 2, 3, 4, 5, 6. And then let's think about my P hat. If I select 0 female, what's the proportion, sample proportion? What's the sample proportion? 0. What's the sample proportion for 1 female? 1/6. Okay, there's 1 female out of 6 people. How about if it's 2? 1/3. How about 3? Yeah, 4, 5, and 6 female. 1. Okay, so my p hat is varying from sample to sample. If I get a sample looks like that, I'll have 0. If I have a sample 1 female and 5 males, I'll have a 1/6. So my sample proportion is changing. Okay, it's changing. I might have 0. I might have a 1/6. I might have a third. I have a half. I have 2/3. So these are all the p hat values, but your p always equals to 0.6. But think about this. I don't want to talk about math yet. Just think about to get a sample of no females and get a sample with 3 females and 3 males. Which one is easier to get? Like I have 9 females in my sample, like I get 6 men. And compared to a sample, I get 3 men and 3 women in that sample. Which sample is easier to get? 3. Okay, the 3 female. Because I have 60 females already, and how you can avoid all of that and just get 6 males is possible. Okay, it's possible. But if you think about the chance of getting 2 different, like the group A and group B sample, group A will be a smaller chance to get, and sample B has got a higher chance to get. So that's why I talk about the probability of getting those 7 numbers are different. They are not equal likely. It's not 1/7 of the chance to get 0, 1/7 of the chance to get 1/6. They are different. Okay, they have different chance to get different values. Okay, how do we find the chance? That's what we're looking at next. Okay, how do we find the chance? Let's have a look at 17b. Okay, so the exact distribution. Okay, this is the first thing we use, the exact distribution, NCR. Okay, we use the NCR now for the exact distribution of sample proportion. Okay, for this type of question, when do you use NCR? Okay, a couple of requirements. First, population is very small. Second, population amount is given. How many in total is given? Okay, that's the 2 requirement you will have. Small population, and it is telling you. Okay, so population is given. So there are, well, look at the next question. A fish tank contains 8 gold and 8 red fish. How many are there in total? 16. 8, 8. Okay. 8 gold, 8 red. Let P be the proportion of red fish in the tank. What P equals to? What P equals to? 1/2. Okay, half of the fish is red, so P equals to 1/2. That's a certain value, it doesn't change. Okay, a sample of 3 fish is taken from the tank without replacement. Okay, the third requirement is without replacement. Well, think about that. If you talk about proportion, you're not going to replace things back, right? Like you just grab a group of something. You're not going to say, pick one, look at the color, throw back, and then pick again. You still pick the same thing. You pick 3 times and pick same fish for 3 times. That's not the way how we calculate things. We want without replacement. Okay, we want without replacement. You're not going to replace the thing back and still have chance to pick the same thing again. So 3 requirement, very small population. Population number, you know that, is 16 in this question, and it's quite small. And without replacement. And I know my PP is a half. This type of question is not practical, okay? It's not the real life situation question. That's not how you use sampling. Okay, that's not how you use sampling. If you already know there are 16 fish, 8 gold, 8 red, and why you want to find a sample still? Like there's no no point to find a sample of 3. For what? For fun? Like that's not fun. Math is not that fun. So like it's not a real type of question. Okay, it's just this is a leading question to make you understand what's sampling. Okay, so now you want to pick 3 fish. Okay, you want to pick 3 fish. Okay, what are the possible values of the sample proportion p hat of red fish in the sample? Okay, of red fish in the sample. Like think about A. I'll draw a grid table. This is the number of red fish. And this is the p hat. And the next line, okay, if that's a random variable, if that's an x, the next line will be PRX equals to x, right? For discrete random variable. So this one is the p hat equals to p. This is a lowercase p. So it's the probability that your p hat equals to p. Okay, question, how many red fish you might have in a sample of 3? 0, 1, 2, 3. That's the possible number of red fish you have in the sample. Okay, what's the p hat equals to if you have 0 fish? 0. If you have 1, 1/3, have 2, 2/3, and have 3, 1. Good. No, 2. 2/3. Good. Now we look at what is these values. Okay, what's these values? What's the probability? Okay, you have different chance of getting a proportion 0, sample proportion 0. You have a different chance to get proportion a third, different chance of getting 2/3 and 1. How easy, this is think about how easy you can get 0 red fish in your sample. How easy you can get 3 red fish in your sample. Okay, just think about this. Without replacement question, if you remember that, without replacement question, when you choose a red fish, okay, what's the probability of selecting a red fish for your first selection? 4 red, 4 gold, what's the probability of get a red fish for your first selection? Half, right? Half. 4 and 4. 4 red, 4 gold, and I also get a red, so it's a half. If I already get a red one, what's the probability get another red one? 3/7, right? 3/7. Okay, I get a red one. What's the probability again get a red one? 2 on 6. 2 on 6. Okay, so 2 on 6. So you can see every time I reduce the total number by 1 or reduce the red number, the probability change a lot from a half to 3/7 and then 2/6. So it changed a lot. What we want to think about is the not tree diagram. If you use tree diagram, it's too complex. Okay, so you need to consider what you take the first time, what you take the second time, what you take third time. So it's very complex. So I'm not sure if you remember, without replacement question is called a hypergeometry distribution, and you can use the NCR to do that. So we want 0 red fish, which means we want 3 goldfish, right? So the probability will be how many ways I can get 3 goldfish and no red fish. So 4 red fish in total, I want 0 of that. 4 goldfish, I want 3 of that. Over 8 fish. Wait. Sorry. 8. How many fish in total? 8. 8 and 8. And I have 16 in total. I want 3 fish. That's my denominator. Okay, that's my denominator. That's the first one. For the next one, from 8 red fish, I want 1 red fish. From 8 goldfish, I want 2 gold. Okay, 2 gold. And over the same denominator. So I just randomly select 3 fish from 16 fish, how many ways we can do it. And the numerator is how many ways I can get the particular type of sample. And then the total number, the favorable number divided by the total number will give me the probability. And for this one, I have 8 select 2, and 8 select 1, and then 16 select 3. And for the last one, I want 8 select 3, 8 select 0, and 16 select 3 as well. That's the different probability. You will get different sample proportion. So what's the first one equals to? Menu 5, 3. 8, 3. 16, 3. This is 1 on 10. Okay, this is 1 over 10. If you use calculator to do that, that's 1 on 10. You have 1 on 10 of the chance to get a proportion 0. Okay? If I'm not looking at the tank, okay, just pick 3 fish. Look at the number, look at the color. There's no red fish at all in my hand. I'll say, oh, the proportion is all goldfish in that tank. What's the probability I can get that conclusion? Is 1 on 10. Because it's only 1 on 10 of the chance I can get such sample. And I can make the conclusion that the proportion is 0. For the next one, 8, 2 times 8 over 2 on 5. So here is 2 on 5. And you can see the next one is the same as the first one. It's just you change the order, but they are the same thing. Okay, so it's 1 on 10, 2 on 5, 2 on 5, and 1 on 10. That's the different chance you will get such sample. Okay, you get such sample. All right, that's for A, okay? So what are the possible values of sample proportion p hat of the red fish in the sample? So the possible p hat is 0, 1/3, 2/3, and 1 in 3 samples. And the probability of getting those 4 proportion is 1 on 10, 2 on 5, 2 on 5, and 1 on 10. So this is a probability distribution about sample proportion. Okay, so it's a combination of what we learned for the first previous couple of chapters as well. So this is a probability distribution for a sample proportion. I don't really need the first row. Okay, I don't really need this row. This row is telling us how many red fish I have and what proportion I will have. But for actual population proportion, I just need the second row and the third row. That will be a proportion, sample proportion distribution. Okay, sample proportion distribution. Let's look at B. B is determine the probability that the proportion of red fish in the sample is more than 0.25. Again, you want the probability, proportion of red fish in the sample. So it's the sample proportion. What we'll do is probability. I'll write here for B. Probability of capital P hat is more than, greater than 0.25 equals to what? 0.25 is a quarter, right? Where's a quarter? Here or here or here? Where's a quarter? Between where? Here? Yeah, so it's between this. So greater than this value. So all the value except 0 will be a value greater than 0.25, right? So I just use 1 minus 1 over 10. So that's 9 on 10. Okay, that's 9 on 10. How you can get a sample and you get a conclusion your sample proportion is more than 0.25 is 9 over 10 of the chance to have such probability, a sample proportion. Okay, for C, find PR, P hat equals to a third, given P hat is greater than a quarter. What's the intersection between those two? P hat, intersection is just P hat equals to a third. Divide by probability. P hat is more than a quarter. For an interval intersects with a point, the intersection is just that point. Okay, for an interval intersects with a point, the intersection is the point itself. So which is equals to a third. So what we have here is 2 over 5 divided by 9 over 10. Okay, greater than a quarter is what we worked out before in the previous line. 2 over 5 is the probability that your P hat equals to a third. Divide by greater than a quarter, that's 9 over 10. Okay, we times by that, that is 4 over 9. Okay, 4 over 9. That is 1, that is 2, so that's a 4 on 9. Right, everyone, I want you to use the rest of time to work on example 4A and B. Well, I can check answer with you in the end. But I want to change this question a little bit, everyone. The 4 red ball, I want to change to 3 red ball. Okay, you only have 3 red ball in this question, okay? So I want you to do the question. You have 6 blue ball and 3 red ball. And then you have a proportion size 4 as a sample. Okay, size 4 as a sample. And then you want a distribution. We want a distribution. So first of all, I want to create a distribution table like this. Okay, a distribution table like this. And then answer the question. The first question is, what's the P hat greater than a quarter? And determine the mean and standard deviation for the P hat. So if you can set up this table using the NCR, everything will be easy. Okay, just start doing that first. I'll check answer with you later. Okay, just explain my answer a little bit. Because I changed the question, I changed it to 3 red balls only and 6 blue ball. And I'm talking about the proportion of red balls, okay, in the sample size 4. So how many red balls I can actually take is only 0, 1, 2, or 3 red balls. I can't take out 4 red balls. You will definitely have 1 blue ball in your sample, like you can't avoid that. So the proportion I can't have 1. I can't have a proportion of 1. I have a proportion of 0, a quarter, a half, and 3/4. That's my sample proportion. Okay, so to get 0 red ball, which means you get 4 blue ball. So if 6 select 4, and 3 select 0. Divide by 9 select 4. So 9 select 4 is the total number of ways I can select 4 balls from that 9 balls. And the top one is the preferred way I want. How many red ball I want? I want 0. Then 4 blue balls. So 6 select 4 and 3 select 0. So for 1 red ball, I want 3 select 1 and 6 select 3. That's the number of red balls and blue balls. And then the 2 one is 2 and 2. So 6 select 2 and 3 select 2. Then I want 3 red ball, which means there's 1 blue ball. So 6 blue balls select 1 blue ball, and 3 red balls select 3 red balls. So basically one situation, just select all red balls. And then how many different 6 blue balls you can have? Divide by 9 over 4. So denominator is always 9 over 4. That's the total way of selecting 4 balls from these 9 balls. And then I use calculator to put that in. The NCR put in, I have 5 over 42, 10 over 21, 5 over 14, and 1 over 21. So that's the probability of getting that p hat. Okay, that's the probability of getting that p hat. So the next one asking for probability your p hat is greater than a quarter. Okay, so greater than a quarter. So greater than a quarter is not including a quarter. What I will have is a half and 3 quarters. I will have 5 over 14 plus 1 over 21. And I got 17 over 42. Okay, 17 over 42. Next one is expected p hat. Okay, expected p hat, which is a quarter times, well, expect p hat, you know, like that's the probability distribution for the table one. You just vertically times all of it and just adding it together. That's how you calculate expect values when you have a table. So I don't really need the first line. First line is just help us to work out the second line. So I can hide the first line, the second line times the third line, and adding them together. So I have a third. Yeah, I have a third. Okay, let's think about a third. What is really a third? Why is such a nice number? How you can work out the third? It's not something that surprised me. I'm expecting a third. What's the P in this question? What's P in this question? How do you calculate that?
3 out of 9.
3 out of 9. So which is a third? So what conclusion we have here is your expect p hat should be same as your p. Okay, expect p hat, like that's the next thing we'll talk about next lesson. But you can see, you can question yourself why we have not a very nice number in the probability, but why in the end I have such a nice number? Because it's the p-value. Expect p hat should equals to p. Okay, should equals to p. Expect p hat equals to p. But next lesson we'll talk about that further. And variance of p hat is expect p hat squared. So how do you calculate expect p hat squared? Well, you just treat p hat as x and x squared. So it's 0, 1, 6, 1, half, 1, 16, 1, 4, and 9 on 16, and then times the probability and adding them. So 1, 16 times 10 out of 21 plus a quarter times 4 on 14 plus 9 over 16 times 1 on 21, and I calculate that equals to 7 over 48. And variance of p hat is expected p hat squared minus expect p hat and then squared. So I get 7 on 48 minus 1 on 9, and I have 5 over 144. And standard deviation, just square root of that value, is square root 5 over 12.
Isn't that just like discrete probability? Like with the discrete probability table?
Yes, exactly the same thing. It's exactly the same thing. Just how we can set up the table. This is only the first method to talk about sample question. There's like binomial and there's normal. Like there's different ways of talking about that. That's one of the distribution we use is a table, discrete distribution table we use. So all the ways we calculate variance expect values all the same as how we do it before. Okay, the only new thing is what is sample? Do you understand what sample proportion? It depends on this sample, what's the eligible number you get, and then divide by the total. That's the sample, and it's a random variable because it's changed from sample to sample. Okay, so that's what we want to talk about today. That's the first type of distribution we have, is the exact one. Okay, when we can use that is the population is very small and we know the exact population is given to us, and I know this is a without replacement question. If it's under those conditions, then I will use this table method to calculate the probability. Okay, tomorrow we'll go for the next one.